Welcome back to the first episode of 2025. Today, we have a listener request from Tomasz out in the Czech Republic, wishing to learn more about oil beetles. These little critters are packed with surprises, from their deceptive survival strategies to their connections with ancient practices. By the end of this episode, you'll see why oil beetles are much more than meets the eye. So, let's get into it. Let's start with the basics. What are oil beetles? They belong to the genus Mello, within the family Meloidae, commonly referred to as blister beetles. The family name Meloidae is derived from the Greek words melos, meaning limb or extremity, possibly referencing their distinct, often elongated body shapes. As for their common name, oil beetle, it comes from their ability to exude an oily toxic substance called cantharidin. That being said, many of these beetles look like they were dunked in oil because of their shiny black exoskeleton, and their abdomens protrude out from under their elytra like a large oil drum. They don't look like this from the start though. The abdomens only fill out after they eat their first meals as adults, and females naturally have much larger ones than males due to the eggs they have to drag around. And yes, they really do have to physically drag their large abdomens around because of how large they are. Within Meloidae, oil beetles are closely related to other blister beetles, like the Spanish fly, Lyta vesicatoria, which is indeed a beetle and not a fly. These beetles' evolutionary adaptations make them fascinating subjects of entomological research, and we will be getting into that soon. But first, let's look at where they can be found. Oil beetles are widespread, with species found across Europe, Asia, North America, and parts of Africa. In North America, you are likely to encounter species like the black oil beetle, Mello americanus, while in Europe, you can commonly find the violet oil beetle, Mello violaceus, and the European black oil beetle, Mello proscarabeus. Their habitats vary depending on the species, but generally they can be found in temperate grasslands, meadows, and open woodland. They favor areas with loose, sandy soil, which is crucial for their unique reproductive strategies. You see, these beetles, unlike many other traditional species, rely on parasitism to complete their life cycle, specifically with solitary bees and a behavior called foracy, a form of hitchhiking. After a female oil beetle mates, she begins looking for a safe place to lay her eggs in the ground. She will start digging out a small ditch with her mandibles, and then once the hole is large enough, she'll finish the job using her legs and abdomen until she can back down into the hole completely. She lays hundreds to 1,000 eggs in this deep hole and buries it upon completion. You might think that's a lot of eggs for just one burial, but the odds of a single egg making it to adulthood are pretty grim due to the larvae needing specific bees to survive. When the larvae hatch, they climb onto flowers and wait for a pollinator. But wait is a bit misleading, because the reality is that these larvae have a variety of tactics to attract the right bees, most of which involve luring a male solitary bee to the flower, where they can hitch a ride in hopes of finding a female after. Some tactics include pheromones that smell like a female solitary bee, or visual mimicry of a female bee when multiple larvae gather together. Individually, these beetle larvae look like mini earwigs, and they have interesting hook-like feet which they use to latch onto passing solitary bees. Actually, some people refer to the larvae as triungulins, on account of the 3 hook-like claws they have on each foot. Anyway, once the larvae get dropped off in a solitary bee nest, the beetle larvae consume the bee's eggs and stored pollen, ensuring their development into adulthood. The bee has no idea any of this is happening though, because solitary bees usually seal off their nests after laying their eggs and move on. The process happens slowly over the course of 2 to 3 months, and the adult beetles usually emerge from the bee nest in spring. What's interesting is that once the larvae molt into their second instar, they appear more like a grub and become increasingly inactive after their 6th instar until pupation on the 8th. Now, because the larvae happen to be parasites on solitary bees, the presence of oil beetles is often an indicator of a healthy ecosystem. Their abundance can hint at a thriving bee population in the area. However, habitat loss and agricultural practices have led to declines in both bees and oil beetles, making them a valuable bioindicator species. Oil beetles also have a seasonal cycle that's closely tied to their host bees. In temperate regions, adults typically emerge in early spring, with peak activity occurring between March and May. This timing coincides with the emergence of solitary bees, ensuring that the beetles' larvae have access to their hosts. During the warmer months, adult oil beetles can be seen roaming meadows and grasslands searching for mates. And speaking of the adults, you might be wondering if they eat bees too. And the answer is no. Adult oil beetles are phytophagous, which means they feed on plants. Everything from flowers, stems, leaves, etc. Aside from their meal preferences, adults offer their own distinct behaviors, like chemical warfare. When threatened, they release a toxic yellowish oil containing cantharidin from their leg joints, and they also play dead. This substance can cause blistering on human skin and is highly toxic if ingested. For predators, it's a clear signal to back off. Adult beetles also have an interesting courtship, where the males will ride atop females and use their antennae and legs to coerce the female into copulation. This is separated into two stages. One, the dorsal stage, where males simply ride on a female's back without doing much of anything else, and the second stage would be the display stage, where males rub their antennae on the females and use their legs to rub the female's abdomen. All in all, this courtship can last between 15 seconds to 15 minutes. Once the mating has finished, the males and females will go on their merry ways to potentially do it all over again with a completely different partner. You see, these beetles don't feel any attachment to each other, and males don't even fight over females. Now, I do have to mention that the courtship lasting between 15 seconds and 15 minutes is just the whole display and dorsal stage. The actual mating process can take up to 8 hours. Now, before we wrap up this episode, I want to quickly get into some of the applications for their toxic secretions over the years. As mentioned at the start, the toxic compound produced by oil beetles is called cantharidin, and it's historically known for its medicinal properties. Ancient Egyptians used it over 3,000 years ago to induce contractions during childbirth, and the ancient Greeks valued it as an aphrodisiac, healing salve, and poison for assassinations or executions. Today, oil beetles are a symbol of biodiversity and the intricate connections within ecosystems. Their dependence on solitary bees highlight the importance of pollinators and the delicate balance of nature. And that's going to wrap up today's episode. Please make sure to rate the pod on whatever platform you listen to. And of course, check out the Patreon for a large backlog of monthly bonus episodes, ad-free episodes, and vlogs. If you have your own request, please send it in to insectsfordummies@gmail.com, and I'll get working on it as soon as I can. And thanks again for listening.